Hello and welcome back to another video where we're building our multiple linear regression. In our previous video, we loaded the data into StatCrunch, and now what we're going to do is we're going to look at the rushing variable. So we have the data, we're going to build a simple linear regression from the running yards per game and use it to predict the points per game. Okay, so I'm going to go over to my data that I have uploaded. I'm going to go to stat regression. Now, you can use the simple linear here, and that will give us access to some different tools. But what we're basically doing is we're doing a build up model for our linear regression. So I'm going to build a multiple linear regression, and my response variable is going to be the points per game, and my predictor variable is going to be the rushing yards per game. So this is like, how does average yards rushing translate into average points per game? Here, we're only evaluating the model. So what I want to look at, excuse me, what I want to look at is not necessarily the intercept. The intercept is almost always statistically significant. What allows us to interpret the intercept is whether it makes sense for rushing yards per game to be 0 as a predictor for the points per game. Now, can you have 0 yards rushing in a game? Yes. Is that a common occurrence? No. So this intercept probably is not interpretable. But what I want to do is I want to look at the rushing yards per game, and I see that that value is not statistically significant. It's about 0.12, which is greater than our typical alpha level that we use of 0.15. Because I only have one predictor, my model has exactly the same p-value. And so because it has exactly the same p-value, this model is not doing a very good job. And then finally, I want to look at our r-squared. Our r-squared is only 6%. Given the insignificance of my p-value and given the very small r-squared value, I would say that this is not doing a very good job. Okay, so now that we've looked at rushing, let's look at passing. And does passing do a better job helping us explain the model? So what we're going to do is go over to our stat, regression, multiple linear. Again, we're going to select our points per game, but now we're going to select passing yards per game and see how well it does. I click on compute. Okay, and so as we see here, again, the intercept is statistically significant, but is it really interpretable? Can you have 0 passing yards in a game? Yes. Is it likely to score points in this way? No. And so the intercept here is probably not interpretable. But the passing yards per game is statistically significant. It's well less than 0.05, and it's even smaller than 0.01. So we would definitely say that this is significant. Because we only have one predictor variable, our p-value is significant for the model. And if we look now, our adjusted r-squared has gone from a measly 10-11% to almost 34%. So triple what we had with the rushing yardage. So this is a big improvement. Okay. Now, because this model is doing a good job, we can see it finally explains the 34% of the variability. What if I do a multiple linear regression and I do a quantitative one? In football, you actually need to run and pass the ball. Maybe we should see if both variables together create an actual better model. Okay, so let's go ahead in here. Let's click on our options and edit. And now let's go ahead and scroll down and shift click the rushing yards per game. And now I have a true multiple linear regression with two predictors for my response variable. I'm going to click on compute. And now as I can see, whoa, what happened here? Now again, the intercept is statistically significant, but now it is predicting a negative number of points. You can't have a negative number of points in a game. Only positive points are awarded. So this intercept is definitely not interpretable. Now, the passing yards per game is now even more statistically significant. It is now less than 0.0001. Look at what happened to the rushing yards. The rushing yards per game is also now statistically significant. When you build your model, this will happen. As you add and subtract certain predictors, the p-values are going to change. Here, the p-values changed in such a way that rushing is now statistically significant. As we look at our model, while it has the same values as these two, it really is a different value. We would have to plug it into a stat calculator to try and figure out what the difference in p-value is. But let's just say this is a very good model. It's doing a very good job of predicting. In fact, the r squared, and now the adjusted r squared is appropriate, is basically 85%. So this is explaining 85% of the points, which makes a lot of sense because there's only a couple of other ways to score besides passing and rushing, kicking field goals, safeties, and a couple of other things. And so we're explaining 85%. Now notice that the 11% from rushing in our single linear and the 35 from our passing regression does not add up to 85. So I'm explaining way more of the points with this than with the two alone. This is the power of a multiple linear regression. Now, this is really good. So how can I make the model better? All right. Now, ranking is one of the things that we have. And so if I look at my data, ranking first, second, third, fourth, all the way down to 25th. This is ordinal level data. At least it might be interval level, first, second, third, fourth, fifth, right? And so can I treat this as a quantitative variable? It's hard to say, right? So let's see. Do the ranking variable, which is also quantitative. It's on an interval scale. We can look at the histogram of the ranking and do the Shapiro test on the ranking, okay? So how do I get a histogram? Graph, histogram, I'm going to do rank. I'm going to go ahead and overlay a normal distribution to help me see that, and I'm going to go ahead and click compute. Well, you can see that it looks fairly well symmetric. It's actually kind of uniform. This is funny because really you just have 1, 1, 1, 2, 1, 3, 1, 4, right? And so the histogram here is actually kind of silly, but it doesn't actually look too bad. If you want to do the Shapiro-Wilks test, you're going to go to stat, goodness of fit, and the normality test. I'm going to click on the normality, and I want normality for rank. And let's go ahead and look at the QQ plot as well. I'm going to click on compute. You can see that the Shapiro-Wilks test is not statistically significant. This is good. The hypothesis test for the Shapiro-Wilks is that the data is normal. So rejecting it would mean that the data is not normal. So this is looking pretty good. And if I go to the QQ plot, it is very close to the red line, all of the data. It is a little wiggly, but this is not too bad. So really, this is at least ordinal. It's looking pretty good as interval level data, and so you can probably treat it as such. So let's go ahead and add that to the model to see if rank helps us do better. So we're going to go to multiple linear regression. I'm going to again pick points per game, and then we're going to have passing yards per game, rushing yards per game, and then I'm going to add rank at the end. And again, I'm holding down shift and I'm clicking to get each of these here. Okay, so now I go down, there's my hypothesis test, right? We're going to go ahead and leave all of these alone. I click on compute. And here, again, our intercept is negative. It's not interpretable, even though it's statistically significant. The passing yards and the rushing yards stay at very small, statistically significant values. But the rank is not statistically significant, and it's actually made our R squared a little worse. Our ability to predict went down a little bit with this particular variable. So what we would want to do is we would want to remove rank because it is not significant and because it's actually reducing the explanatory power of our model. So now we've assessed our model with the ranking. We can go forward, and in the next video, we can talk about categorical variables and dummy variables. And if that inspires you, if you understood that